Okay, sample test, multiple choice number 2. We got says evaluate x cosine 2x. Nope, wrong one. Say that's going to require something that you don't know. So good thing it wasn't that one. All right. So bottom line here is that we have the graph given here, y, and it says find the area of the region bounded by the x-axis in the graph of this function. And ultimately, if we take a look at the function, we can see that it's a cubic function. I would suggest that since we're going to have to anti-differentiate in some capacity or another to multiply that out and just get a cubic. So if we do our x plus 1, leave that alone, this squared is going to be x squared minus 4x plus 4. Go. Alright, and if we multiply it by the x plus 1, we're going to get x cubed minus 4x squared plus 4x plus x squared minus 4x plus 4, which will ultimately give us x cubed. The two x squareds here, these would make 8, or no, these x squared, sorry, negative 3x squared then. These two would be gone, and we just have plus 4 here. We got a 4x and a negative 4x. Questions so far? Alright, so the next part here again is just find the area of the region bounded by the x-axis and the graph of this function. And if we want to find the zeros of this function, in other words, develop a graph for it, if you will, so we can see what we're going to want to integrate here, we can see in factored form. To get the zeros here, we already have it in factored form. One of the zeros is negative 1, and the other one would be 2. And so those being the zeros, knowing the nature of a cubic function, we know that it has to, negative infinity, it's going to be going down, positive infinity, it's going to be going up. So ultimately we have to come up through this 0 and then go down at this 0. And remember one thing that we also know too, since this is a double root, if you will, that's going to be a point that hits the x-axis and goes back. So ultimately the shape would have to be something like this. Okay. So learned something new today if you didn't. Okay. Alright, so bottom line here is that when we set out to find the area of this, if you will, okay, what area are they referring to? Okay. Well, really the only area that would make common sense would be that shaded area right there, wouldn't it? So the area bound between the x-axis and the curve. So if we go from negative 1 to 2 of our function, which is x cubed minus, that is 3x squared plus 4, and we anti-differentiate. And let's see what happens when we plug a 2 in there. If we get a 2 in there, that's going to be 16. 16 divided by 4 is going to be 4 minus 8 plus 8. And a negative 1 in there is going to give us a quarter. Negative 1 in here is going to give us plus 1. Negative 1 here is going to give us minus 4. So in the parentheses I have a 4. And in this parentheses I have 1 and a quarter and a negative 4. So it'll be negative 2 and 3/4. So in that parentheses I'd have, again, 1 and a quarter minus 4 would be 2 and 3/4. And adding those together, because it's a plus plus situation, we get 6 and 3/4. Matches up with letter E. Hopefully that's what I said, right? Okay, questions on any part of that one? What else? Number 3, we have x squared secant squared of x cubed. And we ultimately want to know which of the following is an antiderivative for this function. Well, if we're going to have to anti-differentiate this, we know that that's certainly not a known derivative. Okay? And so we might suspect here that since our secant squared of that argument has a derivative that's related to x squared, that our u substitution here would be the x cubed. And why? Because the du would be 3x squared. So again, if we were going to integrate this, we would have our x squared and our dx in a sentence. together, here and here. And so our substitution then would be secant squared of u. And then our x squared dx we could get rid of with 1/3 du. Because if du equals 3x squared dx, then 1/3 du equals x squared dx. So we'd have a 1/3 out here, du here. And now it is a known derivative, because what's the antiderivative of secant squared? Tangent. We'd have tangent u plus c. So that would be our answer in terms of u, but then we're going to go ahead and plug our x cubed back in. So x cubed plus c. And looks like the only option there that matches up would be c. And ultimately, remember it says which of the following is an antiderivative. Remember, this plus c could be anything here. It could be minus something, plus something, whatever the case may be. What has the right form would be letter C. What else? 1 through 14. Number 4, we have, says the line L is normal to the curve defined by 2xy squared minus 3y equals 18 at the point 3, 2, and then we want to know the slope of the line at that point. So ultimately, we know normal lines and tangent lines have reciprocal slopes. So if we find the tangent line slope, then we'd be able to find the normal line slope without too much trouble. So as soon as we see that, though, what should come to mind? Plus the differentiation. And what should come to mind as soon as we see that? So what? It's product. So derivative, or first times the derivative of the second's derivative would be 2y dy dx plus the second, y squared times the derivative of the first, times 2. And then on the second part here, remember that right there is the derivative of 2xy squared. The derivative of 3y would just be 3 dy dx. And the derivative of 18, of course, is 0. So if we collect the terms that have dy dx, then over here we'd have 4xy dy dx minus 3 dy dx. And then on the other side we'll put the other term, which is negative 2y squared over there. So we'll take that and ship it over to the other side. And then if we factor out the dy dx out of these two, and then divide, we can get our dy dx to be negative 2y squared over 4xy minus 3. Alright, and the point in question is what? 3, 2? So if we put a 3 and a 2 in there, we're going to get negative 2 times 2 squared. And the bottom we have 4 times 3 times 2 minus 3. So all told we'd have negative 8 on top. On the bottom we have 24 minus 3, which would be 21. So that would be the slope of the tangent line at that point. So therefore the slope of the normal line at that point would be 21/8. So this would be the tangent. Normal would be opposite reciprocal, because those two lines are always perpendicular to each other. Therefore, choice A. Questions on that one? Alright, next. Number 6, we got our function this time is y equals 1 over x plus radical x. And it says find the value of x at which the graph has a point of inflection. So points of inflection have to do with what? Second derivative. So y prime here would be this being x to the negative 1. The derivative of x to the negative 1 would be negative 1x to the negative 2. And actually, for convenience sake, I'm just going to leave it in that other form, so it'll just be negative x to the negative 2. And then x to the 1/2 would be 1/2 x to the negative 1/2. And again, I'm just going to leave them in that power form because I'm just going to differentiate again, and I'll want it in power form. It would be easier to find the derivatives. So y double prime here would be 2x to the negative 3, and then negative 1/4 x to the negative 3/2. And if I rewrite, I'm going to get 2 over x cubed, and then over here I have 1 over 4 times be the square root of x cubed. Power on top, root on bottom. Alright, so ultimately this is going to have an inflection point when this equals what? 0, or when it doesn't exist. Okay, and keep in mind here that when it doesn't exist, the only option for that would be the 0 here. 0 on the bottom in both of those spots. Okay? And keep in mind that 0 is not even part of the domain, so that's really not an option for us. Okay? And we know that the actual domain of this is, again, 0 is no good. Negatives are no good. So really the domain here is x greater than 0, isn't it? So keep that in mind. So implied domain here is x greater than 0. And so I guess, like I said, the issue is, is there anywhere that this could equal 0? Anywhere where this function could equal 0? So, if it did equal 0, okay, keep in mind that if we want to solve this, if we added the other one to this side, we'd have 4 cube root of x, or square root of x cubed over here, and then we'd have 2x cubed over here. If we can write it as a proportion like that, we could get rid of the fraction part by doing the cross product property. So if we did that, we'd have x cubed, and over here we'd have 2, so it's actually 8 times the square root of x cubed here. Alright, and then from there we would want to do what? Somehow if we're going to solve this, we need to get rid of the radical first, so square both sides, get x to the 6th equals 64x cubed. Squared both sides. And then from there, now if we write it as just a regular polynomial equation here, and we factored out an x to the 3rd, we'd have x to the 3rd minus 64. Which ultimately this solution would give us 0, but we know 0 is not part of the domain. The other solution would come from this, which is 4. X cubed minus 64. Put a 4 in there, that would give me 0, wouldn't it? So that means that 4 would be our candidate. And checking 4 to make sure that we do have a change in concavity here. Because you'll notice that there is no option for none, I guess, so we probably could just circle 4 and call it good at this point. But depending on what our time frame is here, we want to check. If I put something less than 4 in there, I'd have, let's say I put a 1 in there, be a good one. So this would be 2 here, and I'd have a quarter here. If I put a 1 in, right? So that means I'd have 2 minus a quarter, which would be positive. Anything bigger than that, like say, I think of a number that would be nice here for us. I guess the next nice one would be, that doesn't work either. Well, either way, if we put, even if we just pick 5, we put 5 in there, we're going to get 2 over 125. And if we put a 5 into the other one, we're going to get 5 cubed here. And 5 cubed, of course, is 125. Square root of 125 is going to be 5 radical 3. So we're going to get 20 radical 3 over 1. Alright. And I guess the question is, which one of these is bigger? And like I said, there's only one choice here, really. So we can mess around with that and try to see which one's bigger, but ultimately this one better be bigger, so because we want to have a negative here for our second derivative.
Wait, what was the answer number 4? Was it?
That was A, wasn't it?
Yeah.
What's that?
It's A.
Yeah, it should be A. 21/8. Yeah, it does say E, that's not right. Should be a typo. So there's no way that the tangent line is negative 8/21, so it should be A. Alright, what else? Mike?
Number 8.
Alright, let's check out number 8. It says y is a differentiable function. The derivative is greater than 0 for all x. Which of the following values of y for which of the following values of y is it true that the derivative of y squared is equal to the derivative of ln y? So we know that d dx of y squared is equal to 8 times the derivative of ln y. Alright, so again, all we know here is that this function y is differentiable, and we know that the derivative of y with respect to x is always greater than 0 for all x. Okay, so keep that in mind. And ultimately, the question is, for which of the following values of y is it true that these two are equal to each other? Okay, so let's see if we can simplify the left side here. If we do the derivative with respect to x of y squared, okay, we're going to get what? We're going to get 2y dy dx. Fair enough? Okay. And then over here, we have 8 times, and what's the derivative of the natural log of y? 1 over y dy dx. Fair enough? So that would be true. So we'd have 2y here, we'd have 8 over y here, and then again we have dy dx. Get those. Alright, so bottom line here is it says let y be this differentiable function, and the derivative is always greater than 0, it says. And it says which of the following is going to be true, or for which of the following values is this sentence an equality, essentially. So now that we have the sentence here, if we put in the choices that we have here, choice 1 is a half. So if I put in a half in here, I'd have 1 dy dx on this side. And if I put a half into this side, I'd have 16 dy dx. So the question is that sentence true? No. Okay. What if I put in a 2? If I put in a 2, I'd have 4 dy dx on this side. And a 2 in this side, I'd have 8 divided by 2, which is 4 dy dx. And again, since this dy dx is positive, no matter what these dy dx's are, 4 times positive, 4 times the same positive is going to give us an equality. So 2 looks good. What about 4? If I put a 4 in there, I'm going to get, on one side I'm going to get 8 dy dx. And on the other side I'm going to get 8 over 4, which is 2 dy dx. So true or false? False. So it should be 2 only, which is B. Alright, go ahead and pause there at this point.